Hello, everyone, and thanks for joining this Telit and MultiTech webinar, Exploring Real 5G Use Cases from Hype to Reality. I'm Amanda Flink, the Head of Global Events here at Telit, and I will be moderating our event today. Before we start, we would like to understand what your top priority for your next 5G project is. So if you could please take a second to fill out the poll question, which you'll see on your screen now. Now let's get to know our speakers. To explain this topic today, I'm pleased to be joined by two speakers. First, we have Daniel Quant, the Vice President of Strategic Development at MultiTech. Good morning, Daniel.
Hey, morning. Good to be here, enjoying some good conversation and banter today.
Great, thanks. And second, we've got John Keever, the Chief Technology Officer, IoT Platforms at Telit. Hi, John.
Good morning, Amanda. Good morning, Dan. Looking forward to having some good interchange and discussion as we go through this highly interesting topic.
Great, thanks, guys. Just before I hand it over to John to start the presentation, I do have a few quick reminders for our audience. I would like to encourage you to interact by posting questions. We will have time to answer some of those at the end of our presentation. You can simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for some additional information on today's topic. And finally, we will send out the presentation replay link to all attendees at the conclusion of this webinar. And with that, John, I will hand it over to you.
Thank you, Amanda. Get started here. I mean, clearly, there's definitely a lot of energy, expectations, and excitement surrounding 5G. There always has been. This is not something that happened overnight, but there's lots of expectations going forward as well. Trillions of dollars of global sales over the next 15 years. The fifth generation of mobile networks, is something that I think a lot of people have been waiting for, and as the evolution has continued. Today, obviously, a lot of the 5G is deployed around what we call non-standalone mode, or NSA, where the 5G radios connect over the existing 4G EPC or low packet core. But over time, obviously, as the 5G cores and virtualization fall into place, there's so many different features that people are looking forward to beyond that we experience with 4G today. Significantly faster data rates, much lower latencies, guaranteed end-to-end performance, and then, of course, support for billions of things such as sensors, which obviously for the types of things that we deal with, that's very, very important and exciting to us. It all started, a lot of this back with 3GPP Release 15 in 2018, where there's a lot of focus there on extending and enhancing the mobile broadband context, but also introducing newer technologies for the higher frequencies and higher data capabilities, everything from sub-6 and millimeter wave technology, where we had the millimeter wave is much more focused on higher frequencies, from the 24 gigahertz to the 40 gigahertz, but also the sub-6 gigahertz, which you could think of as mid and low frequency bands, with some of the lower frequency bands even being under 1 gigahertz, while kind of mid-range would be 3.4 to 6. But with 5 gigahertz networks, they may be ultra fast, but obviously you have the challenge of some ultra short range challenges there as well. But I'd say one of the most exciting things, that we, have been looking forward to, is the fact that, 5G is the first mobile technology designed for machines and systems, in addition to people, and so consequently, there's more challenges in terms of understanding the designs for the end-to-end perspective and how the networks are going to be used. But that brings opportunities for almost all the constituents involved, in the ecosystem. As we've moved forward, kind of the first generation was the, Release 15 back in 2018, kind of the first phase of 5G, where we had some network slicing, the non-standalone mode, the ability to take advantage of what was there from infrastructure. But now, as of last year with Release 16, with new introductions of things, like the ultra reliable low latency URLLC and our, beyond enhanced the basic mobile broadband, but getting into some of the massive machine type communications as we move forward with Release 17 are very exciting to us, because what this allows us to do is now highly tune the network for the type of application that it's going to be deployed for. So it opens up many opportunities there as well as part of those trillions going into the future. If we take a look at kind of the 5G use cases over history, clearly, we started out in the context of 1G, 2G being very focused on voice services and basic text messaging. But then with the introduction of 3G, we started to finally move data and realize the context of mobile internet. Now, that's not to say that along the way there weren't a lot of machine-to-machine and conceptually IoT type projects solved, but clearly LTE has taken us to another level there, whether you're doing streaming or you're doing low-cat types of capabilities as well, where you might be using a CAD-M or NB-IoT type of deployment, but all within the context of 4G. 5G really takes us beyond that, the capability to really configure for, industrial applications, even down to private instances of 5G as well. And so that's been one of the exciting things that we've been looking at as well. The zero latency concept, clearly, moving forward, there's the capability to have much lower latency, but not zero latency per se, but much lower latency so that you could have more effective even real-time control or near real-time control, the ability to get the data where it needs to go at the time it needs to go there to help you with different types of applications that in the past cellular might have been too much of a risk. I mean, the concept of having the capabilities of Wi-Fi and beyond without the localization and the range challenges is very exciting. Some of the things that the industry analysts have brought forward here, you see a couple, one from ABI Research, where they're looking at the ability potentially to post gross margin by 5 to 13% within Industry 4.0 applications when people also embrace the context of 5G and private 5G as well. But the second bullet from Gartner is also a very interesting reference point for us as well, because today it's estimated that about 10% of the enterprise data is created outside of a centralized data center, where you think of your context of your operations center, your databases, your infrastructure, where all of your business operations are typically being performed. But what they're saying is so much of that data is now going to be created and I guess introduced at the edge as a result of the context of edge computing, whether that's at a gateway level, whether that's at a sensorial level, or within the context of a private deployment within Industry 4.0. So you have that ability to leverage the tuning and the customization and things of that nature. And that's, one of the areas that we've been looking at as how do we deploy 5G in the context of, edge computing or industrial automation.
Hey, John, let me just button in there. So that's really great. I mean, that's really showing us that there's margin to be had here, or additional margin, that more of that intelligence is moving down to the edge. So tell us a bit more about that project then. What are you doing with 5G and edge intelligence?
I'd be glad to, Dan. Thanks for the question. Sure. I mean, we've been working with one of our key vendors on a private 5G initiative focused on industrial IoT. And the challenge here is not just to bring in the context of private 5G, but have a pre-configured, almost plug-and-play type of scenario that could be, scaled to meet the requirements of a particular manufacturer. It takes advantage of the Telit products and services, all the way from our cellular modules to our industrial, gateway software, all the way up through our platform service. And that's, one of the, reasons that we think that the capability to take advantage of some of the key features of private 5G are important to manufacturers.
So why the focus? why the focus, John, on 5G in manufacturing? I mean, there's a ton of industries out there. Why the focus on manufacturing?
Well, I think good point. I think this slide goes a long way in saying that it's kind of three key tenets that we're going to be able to have in the context of private 5G. The fact that the network can be very tailored and optimized for what you need from a standpoint of performance, a standpoint of quality of service, and even to the latency, because not all application solutions within the manufacturing domain are created equal. Some are more time sensitive than others. Others require more throughput than others. So you'll have the capability to do that. The second major tenet of that is the fact that it's dedicated. The fact that it can be dedicated to that campus, to that physical location, so that the manufacturer, who of course, if you said the word cloud in manufacturing 10 years ago, they would have probably tossed you out of the building. But obviously, as cloud computing has been accepted, now the ability for that manufacturer to benefit, by the capabilities and flexibility of the cloud, but also to have control over it, which obviously brings into the third key tenet is security, so that they have control of their infrastructure, their data, and have the ability to manage that and how it grows and where it goes and everything of that nature. So that's, some of the key reasons that we see private 5G being a big step forward for industrial IoT.
Yeah, good points, John. And then, I mean, there's also the benefit of that manufacturing agility, right? Cut the cables. Something we at MultiTech are investigating as well in our manufacturing HQ, how to move that equipment around and be quicker when changing to different products. The real key in manufacturing is to shorten those durations as you change from one type of product to another, and that often requires moving things around, right?
Absolutely. I mean, what you're hitting upon there is a couple of really historic perspectives that challenge all manufacturing processes and assembly lines. Always have. The first is the concept that copper costs money. It's expensive to physically provide the wired network drops to every piece of equipment, on the shop floor, and then maintain those connections over time. I mean, even, changing between the different, modalities of wired network that we have to deal with. So that's one big change. I mean, we have customers that, have actually placed industrial gateways with our software at the workstations on the line, and that cost will be around $2,000 to them. But then when they go to physically drop the network connections and do what they need to do to provide the connectivity, I mean, sometimes that can be 2 and 3 times what the cost of the actual, gateway hardware and software is. So, at the end of the day, the wiring cost in some scenarios costs more than the gateway and the software. So that's one big step forward. And the other one is flexibility. I mean, if you take a look, back to 100 years ago when Henry Ford first introduced the assembly line, you pretty much had a well-defined, fixed track movement system. It may not be linear. It may have turns and curves. It may be synchronous in nature where everything moves at the same time, or it may be, asynchronous where there's some queuing areas and whatnot for different parts of the line to move faster than others, and then to basically balance the line out. But either way, everything pretty much came to the line for processing. You had to feed components to the line. You had to have people along the line. You had to have a certain takt time that you were performing at. And now, with the concept of the flexibility you get with, the low latency of 5G, the capability to now have more and more devices, robotic devices, visual interface devices, metering, scanning, actuation devices connected, in a wireless fashion. Now the ability to be a lot more flexible comes into play. The ability to maybe move assembly components to the product and have a less formalized movement within the manufacturing floor, opens itself up, which could be a large cost savings and delivery of materials to the line and basic material handling cost of that nature. So it's very exciting when you take a look at some of the indirect things that 5G, is bringing to bear in the manufacturing domain.
Yeah, thanks, John. So, when we when we look at 5G, how is it really transforming productivity and how a smart factory operates? Have you got a few examples of that?
Sure, Dan. Let me just take a moment and walk through some of those with you. It actually continues to surprise me on a week by week and month by month basis, the types of challenges that some of our customers are bringing forward. But so what I'm going to do is step through some of the bubbles on this particular this is one work cell within a manufacturing system. You'll see that it, although with the view that you have there, you don't necessarily see that it's a little bit autonomous kind of on its own. But we'll work from left to right there. We can start with that head-mounted display. I mean, the ability to provide, rich visualization, at a headset level, whether that's, alarm notification information, assembly step information for the actual operator, or whether it's some context of augmented or virtual reality glasses where we're able to overlay information and context about what's going on at a sensorial level to the user so they can effectively exist in the context that they're operating for the assembly as well as the data that is there underneath it. And the world of, handheld computing, the ability to have more and more, capable tablets, richer integration with higher performance becomes another area of operation where things can be improved and simplified, and that's always good in the context of manufacturing. Let's take a look at industrial, robots, so where you've got the ability now to have, near real-time bidirectional data integration at a wireless level. In the past, that was a dream. It wasn't a reality. Most always we were dropping copper to any of the control and actuation points along the assembly line. When you think of edge computing, the ability to bring that intelligence all the way down to the edge and deploy things like our logic engine to help sequence and alert and checkpoint what's going on in that cell, and then be able to dynamically change that on the fly based upon either product changes, lot changes, or some type of quality change that might be released along that. Auto-guided vehicles, another large key point that we see 5G very aggressively being moved forward, the ability to have something beyond the realm that's been used in the past in terms of the wireless integration for HEVs. So that's another area that we see 5G playing a key part. And I'll wrap up here with this little setup. So this is just a small cross section, but with the security camera, and I don't even like the fact that it's called just a security camera, because camera and video technology is the next generation of sensing. So the capability to move that data, to be able to more quickly be able to analyze that data, whether it's at the edge or it's back within this privatized cloud, gives the manufacturing world yet another boost in the way that they can provide flexibility and capability to the automation of manufacturing processes.
Yeah, that computer vision is definitely a key area of growth in a number of different segments, isn't it? And when technology guys like us, John, when we look at 5G applications in a factory, it seems like almost anything is possible. But how do you see the adoption process actually evolving?
Well, Dan, it's interesting. This is one of those questions that we all grapple with. And as you ask the question, you actually use the term evolving, and that I think is an important one to take stock in. I mean, no company is going to rip and replace their current wired manufacturing systems. They can take 2-3 years to get in place. They take months to get optimized, and nobody's going to rip it out for the sake of the cost of the wiring or the flexibility. I think what we will see is an evolution over time. I mean, clearly new greenfield plants may be designed, from the get-go with the private 5G in mind, and that will be a lead with technology there. But in the context of our brownfields, I think it will be on an element-by-element basis. You'll probably have a lot of hybrid types of deployments, and where you might be using a more wireless modality in some parts of the plan and continue with the wired and others. But there's also the factor that we have to work at the speed the automation and controls vendors can provide devices as well. I mean, your logic controllers and your robotics aren't going to all pop up next week with a 5G interface on them. So there'll be lots of opportunity there for us, as we work together to provide bridging technology, between the Ethernet and the 5G infrastructures at the assembly line device level.
Yeah, for sure. It's an evolving story. It's not going to happen all overnight for sure. And it's not just manufacturing either, right? Every enterprise is looking for mobility and digitization and keen to see the kind of gains that they can get from 5G. Seems like most every market segment is now actively trialing 5G in their business.
I mean, Dan, you're absolutely on point. I mean, industrial IoT is one of our sweet spots, so we spend a good bit of time there. But from a greater Telit perspective, obviously the demands for healthcare, energy and utilities, transportation, oil and gas, the opportunities are endless. I mean, anywhere you have the ability to have, high performance data channels, high, response capabilities with low latency, 5G is going to find its way there, and I think it's going to revolutionize, almost, every, part of the commercial and industrial world that we live in over time. I mean, most of your cellular technologies have a lifespan of 6 to 8 years, and we're looking at 5G possibly having a lifespan of twice that. So it'll be interesting to be part of this new evolution. Some of the types of things that people do ask us about 5G, though, is, what's the role of the carriers, in the networks, and if you take a look at, how it really is going to affect all of these different market segments, there's no surprise that the carriers will seriously be there. I mean, and there'll be classic 5G deployments, as there has been, for voice and data and video in the past. But now the ability to have that private context will be there. And I think the biggest market opportunity for the carriers, MVNOs, and all of the different constituents involved is the fact that there's a lot of different new application-oriented solutions that could be brought forward. Things that we tried. I mean, obviously, people have been highly successful in certain areas like telematics and whatnot, but now to go well beyond that, to go into more focused applications where that happens to be, manufacturing oriented or healthcare oriented or mining oriented. These are different ways that I think that they can engage now in the marketplace and go beyond just bringing the spectrum. So I think that the ability to drive, adoption of the private networks will be there as well, and really expansion into industries. But I think the main benefit for everyone is, focusing on where the solution and value is. Then they'll have the chance to do a lot more of that now.
Yeah, for sure. A number of industries out there, like, oil and gas, for example, utilities, they've been managing private wireless networks for decades now. So I think they're in a good position to be able to manage for themselves these private LTE and 5G networks. But what about the myriad of enterprises out there? They perhaps get a good handle on Wi-Fi, but are they in a good position to really manage the complexities of cellular? And as you rightly pointed out, the telcos, they bring their own spectrum as well, which can be particularly desirable in particular use cases. It's great for mobility in and out of a private network. So I think we're going to see all shades of grey here. There's definite upturn and opportunity for the operators, but there's also the opportunity for those who can do it to just deploy and manage it themselves. So it'll be interesting to see over the next few years how that operator role plays out here in private LTE and 5G.
I completely agree. I think there's going to be opportunity for all of us, at every one of the levels. It's an interesting time. I mean, right now, from the new radio technology and industrial segments moving forward.
Yeah, definitely. So did you know, John, that budget 5G smartphones are now under $500? Which is crazy, right? I mean, under $500 already. And I think part of this is the maturity, right? Yeah, well, it makes me happy as well. When your module price is going to come down, John. Only joking. So there's hundreds of millions of 5G devices out there, and they're deployed globally. At the top of the league there is China Mobile. They got 180 million 5G NR capable device connections out there, and it's growing by 30 million plus devices a month now. So crazy. Another successful area for 5G in that consumer space has been fixed wireless access and often referred to as WISP, wireless internet service providers, who've been deploying sub-6 gig and also millimeter wave 5G NR networks now to CPEs on the sides of residential and commercial buildings delivering internet and TV services. So these are areas of 5G that are actually quite successful, more successful maybe than you might think already. But when we look at the commercial and industrial segments, arguably the sections of society that have the most to gain from 5G, it's kind of a different story. It's a lot earlier than perhaps the press releases, the rhetoric and the hype that we endure in this industry would lead you to believe. The GSA does a fantastic job counting up all of the different types of smartphones, devices, and 5G industrial devices out on the market. And they've counted 34 now, so they've listed 34 industrial 5G products that have been announced. And of course, shipments of those is going to be far less than what's been announced. And part of the reason, and you touched on it earlier on, is that industry is looking for a more complex set of features in order to be able to truly digitally transform and bring into the 21st century their businesses. And you touched on ultra reliability and low latency, but it's also deployment approaches. You know, we just talked about the operators and how standalone and perhaps non-standalone modes are going to be deployed. And right now today, not all of the 5G bands are supporting in the vendor chain the standalone mode. This is obviously coming. Good examples are the upper portion of N77, which the FCC just sold, $81 billion of licenses of that. The UK has allocated much of that upper N77 as shared bands. Of course, here in the US, N48, which is the CBRS band, is also shared. And those shared bands are technically a Release 16 work item. You know, Release 15 was about the operators and license spectrum. And this is a great example of feature sets that are now just starting to get down to reality in some places. But this hasn't held back the industry. The industry has been trialing out 5G for a while now. So let's have a little look at some of those companies and trials that MultiTech's been involved with. So let's move over to this first one here. So this is about Lufthansa Technic, which is based up in Hamburg. They deployed the first, I think, 5G private network in Europe. It's covering a number of hangars that they have up there. And of course, being in Germany, they've taken the Bundesnetzagentur allocation of that shared spectrum there between 3.7 and 3.8 gigahertz, which is nicely covered by N78 and has been deployed as a standalone network. And they've done that in order to create the stability, mobility within that campus environment and those hangars, and to be able to create a really predictable and deterministic network performance. For example, in this image, if you look a little closer in this image here, you'll actually see that this jet engine is not actually on a plane. There's no plane there in the background, right? It's actually on a tabletop, a massive table. And you can see that the engineer here is looking at wear and tear on the engine in order to try to understand what kind of repairs and refurbishment is perhaps needed during this routine cycle. Historically, Lufthansa had used technologies like Wi-Fi, and they'd seen anywhere from under 100 milliseconds to up to 3 seconds in latency, and this really hinders their ability to be able to capture really high definition images and be able to transmit that data.
That's interesting, Dan. How are they doing the inspections prior to COVID? I mean, did the pandemic actually change the overall work processes they were using?
Yeah, so this is a great example of, not quite knowing how 5G can change the world around us, right? So, yeah, they had this 5G network deployed just before the pandemic, which was really fortunate because it enabled Lufthansa to pivot very quickly how they do a number of the different processes and work in these hangar environments, particularly with this table inspection. So, historically, all of the stakeholders would fly into Hamburg, and so you would have, all the persons at the inspection. So that would be the aircraft owner, maybe it's Lufthansa, maybe it's another airline. You'd have lease companies, inspection consultants, and so on. And with this 5G network, they could actually do all of this remotely and have guys participate virtually. And that's because the 5G network enabled that secure, reliable, deterministic network quality to the point where they could even identify millimeter scratches, which you see the engineer pointing at there, I guess. And with that predictable latency between 10 and 30 milliseconds, they're not getting any pixelation, no jitter, and those images are being securely uploaded at speeds of up to 10 megabits per second securely to the various different stakeholders so that they can really accelerate that decision-making process. Another example, which is also from Lufthansa Technic, is virtual modification of aircraft cabins, VMod it's often referred to. So it's the same network, same campus and aircraft hangar environment, and typically what they do here is that they furbish and refurbish the inside of aeroplanes. So it could be new, could be old, could be airlines like United, American, Lufthansa, could also be private jets like, imagine the Rolling Stones and, their 747 with all their audio-visual equipment, bedrooms, bathrooms, and so on. And how these engineers used to do this is that they would be at their desk, do all their CAD diagrams, big files, well over 10 gig, download them onto a tablet, bring them into the fuselage of the plane, and be able to then fine-tune where all of that furniture, the electrical items, the cable, the plumbing equipment, just fine-tune where all of that goes, and then have to go back to their desk. I mean, it's massive aircraft hangars, right? So it takes forever to get back to your desk, do all the updates, and then download the file again onto the tablet, rinse and repeat. With this network, they're obviously able to do that real time inside the fuselage. So that really cuts down a huge amount of time and effort in order to be able to refit these planes and get them back out and increase the capacity that Lufthansa Technic can take on.
Wow, Dan, that's a great application. How did they go about getting the radio signal that they needed for mobile broadband inside the fuselage? That looks like a major challenge in itself.
Yeah, exactly. Well, that was the other reason why they kept rinsing and repeating by, going back and forward, making the changes, right? Because it's not easy to get a signal. I mean, it was a genuine issue. You can imagine you're inside a metal hanger trying to get a signal into a metal tube. So, particularly not easy with mid-band spectrum. I mean, we're not talking sub-gig here at 3.7 to 3.8. So Technic used high-gain base stations, which would normally be deployed outdoors, and they installed them into these massive aircraft hangars utilizing massive MIMO and beamforming technology that then gets through the plane's fuselage to maintain a really reliable broadband connection with low latency directly to the engineer as he's walking up and down that fuselage and of course all around the aircraft hangars as well.
That's an excellent application.
Yeah, again, another game changer, courtesy of 5G. So moving to another one. This is also transportation here, but this is in the rail industry. It's actually a predictive maintenance use case that High Speed 1 is doing. Poorly, which is one of the system integrators here working on this project or leading this project, they're taking these assets and they're connecting them into digital twins so that the operations team and the executives get a real-time understanding of exactly how the network is working and performing. And you know, the UK has seen double the amount of passenger growth over the last 20 years on trains, and they forecasted another double growth over the next 25 years. So this is just a great example of another industry that's looking to increase automation and autonomy to be able to create an environment that facilitates very rapid decision making. The UK Ofcom allocated the upper portion of N77, 3.8 to 4.2 gigahertz. So that's the target here for the network environment. And as you can see, in the industry of rail here, they need to get off of consumer traffic networks. They don't want that contention. They want the highest level of wireless security, so they want to keep that all inside their own network. You know, I think some of the attacks over here in the US on pipelines and water facilities is great examples of why having networks out of not in contact with the internet, you know, has great value proposition. But they also need coverage where they have their assets. And you can see this engineer here, he's working on trackside equipment. It's the trackside equipment that makes the points go to the left and go to the right. And you can see here a superimposed image of the AR and VR displays that he's seeing on how to service that equipment. And so providing that kind of connectivity in tunnels like that, not going to get that off of a public network so easily. So this is, again, another great example of how private network can really improve the efficiency and the decision making by connecting assets to predictive maintenance forecasts and schedules.
Wow, I mean, you know, this application is obviously focused on condition-based monitoring, where link reliability and your real-time connectivity is an absolute must. It looks like 5G is delivering data integrity in difficult-to-reach places, in this case, underground even.
Yeah, exactly. So, you know, for this use case, you know, the security is table stakes, but it's really about just bringing the connectivity where it's needed, getting off the public network and the best effort networks of a macro network, moving out of Wi-Fi so that you have that more deterministic and predictable network environment to get that near real-time secure connection between the assets and the digital twin. And of course, you know, get that data on-prem into those systems to be able to make decisions quickly across the organization. With this kind of passenger growth, you know, as UK guys, we spend half our life complaining about the rail network as it is. There's not enough time in life to continue complaining. You know, we need to get these problems fixed quicker.
Yet another way 5G is changing the world, right?
yeah, less complaining, one hopes, yeah. So here's another use case, right? This is also a government-funded use case, but it's over here in the US. It's the Department of Defense, which has done a number of 5G projects now that are starting to move into trial phase. This particular one is with the Marine Corps. It's using the CBRS band. Initially, it's kind of adjuncting itself into the CBRS band with an NSA deployment. I've seen others do this now with N78 under the auspice of an STA so that they don't have to have connectivity to a SAS in that local area where they're doing those trials. And ultimately, as the vendor chain starts to deploy more equipment that works in N48 CBRS in SA mode, then these networks will become like the others, just pure standalone 5G networks. This particular use case is about high definition video, and as we highlighted earlier on, video surveillance is really selling it short. This is all about computer vision and cameras as a sensor. It's about security and safety, making sure that only the right people are accessing the building, and that, obviously non-authorized people are not able to access that building. But it's also about operational maintenance and management. I guess a little bit like Amazon. Imagine how you think Amazon must be doing its business. Well, imagine overlaying that to delivering supply lines out towards the forward lines of a war environment. So the DoD definitely looking to automate and digitize most everything really inside their supply lines, and they have well over 1,500 of these warehouses, which they want to be able to have a much better idea of how those assets are moving in and out of those facilities.
Wow, this is really a great example of 5G supporting video-based sensing. It's taken it to the next level. I suspect if the project is successful, that those Marines won't be pushing those pallet jacks. I suspect that they will start using 5G-based AGVs to move those pallets around.
Yeah, exactly. I think 5G means this guy is going to be doing something a little bit more meaningful than pushing the pump-up truck around. And of course, there's so many use cases that the DoD is interested to pursue, like AGVs, for example, to be able to improve its supply lines and better track every stage of an asset through its journey to the destination. Video sensing and high definition video is really just a low-hanging application that immediately solves how to securely manage high volumes of data and use traffic prioritization in order to get those crystal clear images when needed with quality of service, and of course without getting the jitter and the pixelation, which, as we discussed earlier on, is rarely, quality of service and traffic prioritization. It's rarely implemented in public networks where all devices are given a best quality effort there. So I'm going to end with this trial here, which kind of takes us full circle really back to the manufacturing facility. This particular use case is robotic equipment, and a lot of this equipment, as we were discussing earlier on, requires a lot of cables to connect it up, and increasingly these factories are becoming far more agile than they were back in the Model T days, where everything was a fixed production line moving at a similar speed. Instead, these bits of equipment get moved fairly frequently as particular models of products get upgraded, or different production runs of equipment get done. And moving to wireless isn't a brand new concept. In this particular trial, these robots have been controlled with Wi-Fi, but performance hasn't always been great. Latency, like I said before, it can be very variable, and so that doesn't really do well, particularly when some of these robots need to be more synchronized with each other, to analyze something, and then perhaps the next robot needs to kick something off the production line if it doesn't meet spec. So there's timing issues to this that low latency definitely is a pre-requirement for. Also, range and quality of signal. The standard approach to any Wi-Fi problem is just dump another Wi-Fi access point in so that you get a cleaner signal in that area where you're trying to connect those assets. But of course, that creates pollution and noise and coexistence issues for everything else around you, and very quickly that noise floor comes up. And with Wi-Fi, they were using, on average, about a 10-to-1 ratio of 10 Wi-Fi access points to 1 cellular base station. And of course, they still get all of the privacy of the data remaining on-prem. They get much better spectral efficiency and management, courtesy of the SAS allocating all the different eNode Bs or CBSDs, as they're often referred to, on frequencies that are not going to interfere with each other. And they also get prioritized traffic, a little bit like the last example, so that different asset classes of devices can be allocated different amounts of resources. And the high data throughput, the 1 gig plus data performance, this isn't every minute of the day, but this is again when those production lines change or the parts change. In order to be able to do the remote management, the control, download all the intelligence at the edge that enables these robots to work efficiently, that's quite a lot of data. And as we highlighted earlier on, change of the production line time is critical. And so that's kind of where the high data performance rate requirement comes from.
Well, Dan, those are excellent points and perspectives. In our efforts as IoT platforms, we've worked with a number of manufacturing assembly customers who've had challenges with their Wi-Fi networks, oftentimes dropping out on the shop floor. Sometimes they'd end up having to go back and rewire, dropping, wired Ethernets. But in one case, I know of, they actually went and put all of their access points on a Koppen power circuit so that they could reset the entire network at a time, because the assembly line would come to a halt. And if you know anything about manufacturing, downtime costs lots of money. So the need to get everything back online and synchronized was an absolute, impact to their profitability. So I think 5G has yet another opportunity to help us out in that dimension as well.
Hey, that's a good tip from my own house. Maybe I need a cut-off switch for my access points. I'm sick of having to keep going up every few days and turning them off and on again.
You could do it with Laura. But that's another discussion, right?
yeah, for sure. So look, a lot of these trials that are highlighted here have been done using the RCell 700, which is an industrial product that we announced back at CES back in January. We announced it as the world's first industrial sub-6 gigahertz industrial router. And as you can see from the image here, it supports the Telit FN980 modem that enables it to have the 5G connectivity across a wide set of bands, many of which are supported in SA mode. It enables that interplay with LTE for NSA mode, or that failover situation in standalone 5G back to an LTE network as a failover there with LTE Cat20 and 4x4 MIMO. Product also has a Wi-Fi hotspot in it, which is great for connecting up assets close by that are maybe not 5G enabled, but you want to take advantage of that 5G low latency backhaul. And a number of other different industrial interfaces on there as well in order to connect up manufacturing equipment and industrial assets. Dual power supply, so a little bit of redundancy there, and industrial temp range and Ethernet connections. Ideal for multiple video surveillance and compute cameras. Condition-based monitoring, industrial control systems, and so on. And we've deployed quite a few of these now out into a lot more trials than what you just saw. The other product that we've been we've been working on, and is the RCell 200. And this is a very similar platform in compute power, and it has the same Telit 5G modem in it. But this product is a little bit smaller, a little bit more compact. It's supporting only Ethernet and Wi-Fi. And, it's a great kind of product for doing perhaps one video camera, for doing AR and VR, where, again, if you're perhaps 20 feet away from here, you get a pretty reliable Wi-Fi connection, and then you get all the benefit of that 5G backhaul. You can also use it in vehicles for Wi-Fi hotspots, or even on AGVs in order to connect equipment going around a factory or a retail environment. So, without further ado, then, let's have a little look at some of the questions that came in here from the guys viewing the webinar today.
Yeah,
so,
thanks, John. Yeah, really nice discussion that you guys are having today here. Audience, before we get to the questions, I am going to drop just one last poll in front of you on your screen here. If you would like to have one of our experts contact you directly, please respond here on the poll, and we'll be sure to have someone reach out. As Dan said, we do have time for a few questions now, so we're just going to dive on in and see how many we can get to in the time we've got left here. The first question I see, what will change the 5G SA deployments in contrast to the 5G NSA focus today?
You want to start on that, John, or you want me to jump in?
No, you can go ahead and cover that one if you want.
Excuse me. Just drunk something, went down the wrong hole. So SA is where everybody wants to go to, right? So 5G NSA is often referred to as 4.9G because it really uses LTE for everything, the attach, the registration, the setting up of the channels. Everything is done on 4G, apart from when you need to be able to consume vast amounts of data, like downloading content or video. Most operators went with NSA because it was the cheapest and quickest way to start moving towards 5G. Some of the operators have already started to move to SA, and that's where their core network, instead of being a 4G core network, gets an upgrade to a 5G core network, which is a whole lot more feature sets. Some of them we highlighted, like lower latency, reliability, improved data rates, spectrum sharing, and so on. So they get a better core network, which can still connect to 5G base stations, and in some cases can be connected to 4G base stations, so you still have that backwards compatibility. But I think most enterprises are looking to come at this without the legacy that the operators have got. So they're looking to deploy 5G SA where they can get access to higher amounts of bandwidth, aggregate that bandwidth, and be able to deliver a very predictable and deterministic service within a building or a campus environment, and simplifying their network architecture by not having to have the legacy that the operators need because of the billions of LTE phones that are out there. And remember, LTE stands for long-term evolution. So this isn't going to be a sunset quite like the trauma that we had with 2G and 3G. This is going to be we all hope this will be a much more orderly transition out of 4G to 5G, but that'll take many, many years, particularly for the large operators. Not so, maybe, for the enterprises that come at this new.
Thanks, Dan. I appreciate it. The reason I wanted you to take that one is, as poll focus participation. You had addressed that, I thought, very effectively, and specifically from the standpoint of the fact that this is a long-term evolution, and the fact that moving from from an NSA to an SA isn't going to be something that happens overnight. That's going to be at the rate that the carriers choose to do it. But obviously, as the newer technologies for lower latency and higher data throughput, become available, I think the market segments that both of us share or serve on a daily basis will be rapidly taking advantage of it.
Yeah, definitely. What's the next question that we've got in there, Amanda?
Yeah, let's see. Next question I see here. What is the role of a managed service provider?
I mean, I'll be glad to start off on that one, and Dan, feel free to fill in as well. But I mean, clearly we see the managed service providers. If you take a look at the overall context of 5G, some things will continue, to be the same in the context of service delivery for a classic, carrier infrastructure. So managed service providers would obviously have an opportunity for that market. But I think the area where it starts opening up new opportunities for the service providers is when you start looking at a privatized 5G, the ability to have, highly optimized and, configured dedicated networks there for them to bring new applications, new services, basically value-based application solutions, something that in the past, have not been so easy. I think the opportunity for service providers to focus on that domain will be a new, kind of business-changing opportunity for them, an area for them to grow.
Great, thanks, John. Next question I see here. How would 5G utilize energy transformation, which aggregates renewable energy sources, distributed grid with smart functions, electric vehicles, and eventually instant electricity pricing?
Yeah, so maybe I'll jump in on that. I work with a number of these energy segments and lead some groups with some industry associations in the energy industry. And 5G, I think, is going to take a little bit of time before it comes to the utilities. I mean, the utilities don't move at quite the speed that perhaps manufacturing and smart buildings and other segments of the market are moving. But that doesn't mean that energy isn't moving quite fast. Oil and gas, for example, bought a number of the power licenses in the CBRS band here in the States. And I think you'll start to see how the oil and gas industry starts deploying 5G. They have a lot of assets out there, like the utilities, and they need to get more and more information off of those assets. Some of those assets only get polled once a day, and they give a very small amount of data about how they perform. And clearly, to be able to digitize operations, improve efficiencies, and improve compliance, they need to be able to get a lot more data off of these devices. Both of these types of energy industries, oil and gas and utilities, they, as I said earlier on, they have a track record of managing private networks, wireless networks that goes back decades. So you can bet they're looking at this, and it's really all about deterministic coverage, better latency, open standards, a broad ecosystem of vendors that can really help them transform their business. And in the example that you give here with renewable energy, I mean, this is all about demand response, right? And demand response is really focused on latency, right? Especially on some of those high generating assets. So I think that it does come, and I think that there's strong value, but I think you're going to see this a lot earlier in segments of energy like oil and gas before you see it in the utilities. The utilities are now just really starting to consume private LTE. So it's going to be a little bit longer, I think, for the utility companies. But I think they'll extract much of this value that you've highlighted here with private LTE.
Great, thanks, Dan. Next question I see. When can we expect 5G rollout completely in a full-fledged manner for consumers?
Yeah, that's another good question. NSA was deployed very quickly, right? It was the fastest way to get there. A lot of operators are talking about that transition to SA. I think you'll see it in the next couple of years being more widespread. T-Mobile, Singtel, a few others have gone in that direction. But I still think it's a couple of years out before most of these operators have made that transition in their core network.
The top quality, of the different tenets of the release, and then the ability to physically deploy that within the carrier infrastructure. So as that becomes a reality, I think it'll move more and more toward consumer availability. But that's something that only the carriers can set the pace for at this point.
And it ties nicely, actually, John, into the other question there about how important will traffic classification be in the future. One of the big reasons why the operators want to move to an SA architecture is because of those core network features like traffic prioritization, quality of service, and it enables them to start going to the next level where they start slicing their network up, and that then enables them to be able to service a best effort consumer grade network nationwide, but it also enables them to leverage those same physical assets to be able to deploy a slice for a particular, perhaps manufacturing company or enterprise with a different level of service, which is something that really operators haven't done. Even though quality of service has been available in 4G for many years now, really most no public operator did that. But SA gives the ability now for public operators to start looking at network slicing as a real viable approach to providing SLAs for business customers whilst providing the best effort service that they do today for consumers.
Absolutely. It goes well beyond, the concepts of FirstNet and things of that nature. Now you have the ability to, based upon the service level agreement you sign up for with the carrier, to be able to get the type of, low level latency and all that you may need and data throughput more tuned than before, where you'd go and say, okay, I need, a 4G, Cat 4 or Cat 5 type of connection. Now you're actually going to be able to specify another level of granularity on what's there, and the network will be able to deliver it, as well as in the context of the privates, to be able to, on a manufacturing floor, to say alarming and things of notification or line stop types of messaging will have higher priority, obviously over standard methods, transfer for data going back maybe for the work in process tracking. So it really starts to change the whole landscape by which we can deploy solutions.
So look, we got one last question that we can quickly answer here, because I'd love to answer that one about the sports industry that just came in there. We good to just quickly do that one? Right. Well, look, Kishan, thanks for the question. So the sports industry is going to have a massive uptake of 5G technology. All of these sports stadiums are so complex you wouldn't believe. If you've had the opportunity to go to these sports stadiums, they have these DAS networks. They have hundreds of Wi-Fi access points. I mean, they have really been on trying to do better connectivity so that you can upload, all of the pictures you're taking at the sports game. But they're also now moving into more fan engagement approaches as well. So having virtual reality where you put on a headset and it feels like you're sat inside the car with, a famous race driver, and you can see him. You can turn your head and look at him. You're in the car, in the race. And they're trying to do a lot of these inside these stadiums in order to encourage people to continue coming to the stadium and be part of the event, and you can see a massive future there for 5G. The latency and the sort of data performance that you need to make those kind of things happen is extreme, right? And if you're using a public network consuming that amount of data, I mean, it's going to cost a small fortune. So the business case to capitalize that becomes much stronger. And it's even true in things like golf. I learned from one of the outside broadcasting companies a year or so ago that when the golf ball gets knocked down into the hole, the TV and the broadcasting company has a very short amount of time to be able to update that score on the screen so that you and I see, yeah, it did go down the hole, yeah, he did get a birdie. And they're fined per millisecond for how late they are in generating those animations and graphics on the screen for you. So there's a lot of financial reasons here to bring 5G into the sports industry.
Yeah, thank you so much, Dan. I believe that's all the time we've got for today. I do know that we have a lot of questions that we did not get to today, so we will do our best to get those over to the right people and try to follow up with you all. Thanks so much for being so engaged with us till the end here. Also a reminder, please be sure to check your inboxes in the coming days for the replay link of this webinar. John, Dan, thank you so much for the great information today. Thank you to everyone who joined us. Have a wonderful day.